Welcome to Chemtech Laboratory Tutorial. Today we'll be looking at gas laws. Gas laws. What are gas laws? Gas laws help to explain the relationship between pressure, temperature, and volume. And this relationship were discovered by several scientists. Example, the Boyle's law. The Boyle's law explains the relationship between volume and pressure, stating that pressure is inversely proportional to the volume of a given mass of a gas at a constant temperature, and as such the formula becomes P is equals to 1 all over V, and this equal to came in as a result of introducing a constant. Therefore PV is equals to K. That is the Boyle's formula. Same with Charles' law. Charles' law says that a volume of a given mass of gas is directly proportional to temperature. You see, it talks about the relationship between temperature and volume. So as you increase the volume, the temperature increases. If you reduce volume, temperature reduces. The Avogadro's law states that the volume of a given mass of gas is directly proportional to the amount in moles of that particular gas. That is, if you increase the volume, you will also the number of moles will also what? Increase. If you reduce volume, the number of moles will be what? Reduced. Same with pressure law. Pressure law states that the volume, the pressure of a gas is directly proportional to the temperature, provided volume is what? Constant. This same is also applied to what? Hamilton's law, that says pressure is directly proportional to the volume of a given mass of gas. So today we'll be looking at the calculations as regards these laws, so that it will be easy for us to understand how to place our units and our formula. So if you look at the first example, it states that cyanogen, an highly toxic gas, is 46.2% carbon and 53.8% nitrogen by mass. At 25 degrees Celsius and 715 mm mercury, 1.3 gram of cyanogen occupies 0.6678 liters. The questions are: A. Determine the molar mass. What molar mass are we determining? The molar mass of cyanogen. 2. What is the molecular formula of cyanogen? What is the molecular formula of cyanogen? And C. Calculate its density. Calculate its what? Density. So these are the three questions that are from this particular cyanogen as an highly toxic gas. So how do we go about the question? We are going to solve this question. Very easy and simple. Solution. They say cyano, which is first of all, you try to get, the first question is determine the molar mass. And we can only determine the molar mass if we know the relationship between molar mass and gas law. And what is that relationship? The relationship is with the ideal gas equation, which is PV equals to nRT. And when we use the ideal gas equation, we can actually get density, because density says that the mass of a substance is divided by the what? Volume of that particular substance. So density is mass all over volume. And relating it to this, we know that mass of a gas can be gotten from what? The molar mass relationship and the number of mole. So in getting number of moles, we say number of moles is equals to mass over molar mass. So it means if you want to replace your mass here, you have to multiply your molar mass by the number of moles. Therefore, your density will be equals to number of moles times your molar mass all over what? V. So that is what? Density. Now, in this, you cannot relate it as Pm all over ROT is equals to what? Density. So with that, you will now have your density to be your molar mass to be dROT all over what? P. So it means to get the molar mass of cyanogen, you will use dROT all over what? P. And how do you do that? You will first calculate your density. What is your density? They gave us mass of cyanogen to be 1.33 gram and the volume to be 0.6678 liter. So it means density will be equal to 1.33 gram all over 0.6678 liter. So just tap your calculator. 1.3 divided by 0.6678. So it therefore means that your density of cyanogen is equals to 1.99 gram per liter. So that is the density of cyanogen. Now you have gotten the density. Then put the density into the formula, and we have an arrow constant. An arrow is our molar gas constant, and the value of the molar gas constant is given as our molar gas constant is given to us as 0.08206 liter atm per mole per Kelvin. Remember that the value of arrow depends on what? The unit of volume and pressure. So you look at the unit, it's in liter for volume and atm for what? Pressure. atm means atmospheric pressure. So it therefore means that if you are to apply this formula to calculate for the molar mass, you need to convert your temperature to be in what? Kelvin, because the unit of arrow in temperature is in what? Kelvin. So it means temperature, which is 25 degrees Celsius, will be converted to Kelvin by adding 273.15, and this value will be given to us as what? 298.15 Kelvin. Then you will also notice that your arrow value for pressure is measured in atm, meaning that the pressure given to us, which is in millimeter mercury, will also be converted to what? atm. And we said pressure as 1 atm is equals to 760 millimeter what? Mercury. Therefore, how many atm will now give us 715 millimeter mercury? Means when you cross multiply, x atm will be equals to 7.715 times 1 divided by 760. So your millimeter mercury cancels out and you are left with what? atm. So let's quickly do that calculation. 715 divided by 760. That will give us 0.941 atm. So that is the present pressure at atm for this cyanogen to be in what? To be in what? in the mass or volume of the substance. So ATM. Now if you have gotten the pressure, it means the value will be added to the formula. So let's quickly wipe the board and just simply impute the value of density times your R value, liter ATM per mole per Kelvin, times your temperature, which is 298.15 Kelvin, divided by your pressure, which is 0.941 atm. So let's look at the calculation. You see that the atm here cancels what? This atm. The liter cancels this per liter here. The Kelvin cancels this per Kelvin here, and we are left with gram per mole, showing that the molar mass has been confirmed as N is equals to, so let's press our calculator, 1.99 times 0.08206 times 298.15 divided by 0.941. So gram per. So we have calculated the molar mass of what? Cyanogen. Okay, so we have calculated the molar mass. Let's now calculate the molecular formula of cyanogen. From the molecular formula, we get molecular formula through empirical formula. So it means we bring down our carbon and our nitrogen. The percentage of carbon is 46.2%. and that of nitrogen is 53.8%. So you divide the percentage by the molar, the relative atomic mass, which is 12 for carbon and 14 for nitrogen. When you divide through, you will have 3.85, and this you will have 3.84. Then you divide through by the lowest number by comparing the number of carbon and that of nitrogen. When you compare, you take a ratio of it, 3.84, 3.84, and this will give us 1:1. When you have gotten 1:1, it means your empirical formula is Cn. Then your molecular formula will become Cn in bracket N equals to what? Relative molecular mass, which we calculated from determining the molar mass of the question, and we got 51.8, and approximately it becomes 52. Therefore 12 times N by opening the bracket plus 14 times N is equals to 52. If you add them, this will now become 12N plus 14N equals to 52. Add these two together, you will have 26N equals to 52. Therefore, make N the subject of the formula. In making N the subject of the formula, you will have N to be equals to what? 2. So if N is equals to 2, it means that in getting your molecular formula, it becomes 2 times Cn, and that will be what? C2N2. So the question you can now further determine the structure of the compound, and the structure of the compound becomes something like this. So that is the highly toxic gas called cyanogen, and we've gotten our density through mass over volume. We got our molar mass through ideal gas equation, which is PV equals to nRT, and finally we have gotten our molecular formula, which is what? C2N. Okay, so it therefore means that you will impute your parameters into your formula as 0.320 atm times your volume given to us as 0.30 liter, which is equals to your number of moles is what you are looking for. Your R value is 0.0. Okay, so you see that we will multiply this and we will get 0.96. So also you apply the same method in the other side of the board. You have 24.7 n. Make n the subject of the formula by dividing through by 24.7. Then you will have 0.04 moles. So that means the number of moles required for the particular gas in this pressure, volume and temperature is 0.004 moles. So the same is applied here. You apply the same PV nRT to get the value of this. Then we go to the third one, where you calculate for pressure in torr, meaning that when you get your pressure, because the pressure in your R value is at atm, so that means when you get your pressure in atm, you will convert it to torr. And how do you do that? You simply put the parameters into the formula. We have P times 560 mil equals to number of moles is 0.18 mole, and your R value is 0.0821 liter atm per mole per Kelvin times your temperature. Your temperature is 27 degrees Celsius plus 273 in Kelvin. So you look at it again. Your R value is in liter and this is in milliliter, meaning you have to convert this your volume, which is in milliliter, to liter, because your R value depends on the unit of volume, pressure and temperature. So how do we now convert this to liter? We convert it to liter by dividing by 1000. So divide your volume by 1000. You will have P times 0.056 liter equals to 0. When you divide by 1000, it becomes 0.56 liter equal to 0.18 mole times 0.0821 times, add these two together, you will have 300 Kelvin. So make P the subject of the formula. It means P will be equals to 0.18 mole times 0.0821 liter atm per mole per Kelvin, then times 300 Kelvin divided by 0.56 liter. This liter will cancel this liter. atm will cancel. atm will not cancel because we are looking for pressure, but the mole will cancel the mole and the Kelvin will cancel the Kelvin, and we are left with P equals to 7.914 atm. So now that we have gotten atm, it means that we will now find pressure in torr. And how do you find pressure in torr? 1 atm is equals to 760 torr. Therefore means that X atm will be equals to, sorry, not X atm, it will be 7.914 atm will be equals to how many torr? X torr. So when you cross multiply, you have your X torr to be equals to 7.914 times 760. Look at it top. This is ATM all over 1 ATM. So you see ATM will cancel ATM and you are left in top, meaning you are converting it to what? Top. So it means S is equals to 6014.64 top. Thank you. So we'll be dropping some questions for you to practice, and please give us your answer in the comment section. Thank you. Keep watching Tech Laboratory tutorial.
Please ensure to answer this assignment and leave your answer as a comment below. Don't forget to share, subscribe, like, and comment.